Hi, and welcome to Mr. Garofalo's podcast. In this episode, we're looking at your packet titled Proving Similarity Using Dilations and Scale Factors. We're looking at number 8, or example 8, which asks you, is triangle DEF similar to triangle D prime, E prime, F prime? And if it is, we're going to have to describe the transformations that occurred to cause this similarity. So as I look at the original figure, I have triangle DEF. I see that its image is smaller than the original. So this must mean a dilation must have occurred. Remember the characteristics for similar figures are they are a different size, the same exact shape, and they have the same angles. And these two triangles meet those qualifications. I've taken each side and I put in a different color so that we can see the corresponding sides more clearly. Remember, in similar triangles, the corresponding sides are proportional. So if we can figure out the proportions for each of these sides, we can figure out the scale factor. So as I look at side DE, I see that it's 1, 2, 3, 4, 5, 6 units. The side that corresponds to DE on the image is D prime, E prime, and I see that is 3 units. So we're going to write a ratio of the image to the original. So the image, D prime, E prime, 3, the original, DE, 6. If we simplify that, we get 1/2. This is our scale factor for this triangle. We could verify this with the sides that are in red also. If you look at EF, it's 2 units. E prime, F prime is 1 unit. That ratio is also 1 to 2, or 1/2. So we know our scale factor is going to be 1/2. But that's not the only thing that happens to this triangle. What we might want to do is look at where would it end up if we just did the dilation of 1/2. So I'm going to write in the points for F, which is 8, 6, E, which is 8, 8, and D, which is 2, 8. Now if I dilate this triangle by 1/2, if I multiply 8 by 1/2, I get 4, and 6 times 1/2, I get 3. That would put us at 4, 3. 8 times a half, 8 times a half is 4. 4, so that would put us at 4, 4. So again, this is 4, 3, coming from F. E, 4, 4. And D, 2, 8. 2 times a half is 1, and 8 times a half is 4. So 1, 4. I'm going to go ahead and connect those points. So that would be what the triangle would look like if it was just dilated by a scale factor of 1/2. I'm going to go ahead and group these line segments together so we can see the triangle. Okay, so there's the original. This would be the dilation. So something occurred to cause this triangle now to appear down here in quadrant number 4. Okay, we can ask ourselves, was it a reflection? Let's see what it looks like if it was a reflection. If it was a reflection, it would look something like this. So it wasn't a reflection. Maybe it was a translation. So let's count the units here. Well, I don't know if I count units. If I move it down 1, 2, 3, 4, 5, I can't really get it to end up on this triangle. So it wasn't a translation. So the only one we've learned is called a rotation. Now look, if you see, if I rotate this triangle in a clockwise direction, there we go. It'll line up right on that triangle. So since it went from quadrant 1 to quadrant 4, that would be a 90-degree rotation. So we're going to say it was rotated 90 degrees clockwise, and that would put it right here on this triangle. So our answer to this problem is that triangle ABC, or a triangle DEF actually, DEF, was dilated by a scale factor of 1/2, and then it was rotated 90 degrees around the origin. If you use this strategy on each problem, you should have some success. I will tell you that example 7 has a mistake in it, this problem here, so if you want to disregard this one, you can. Good luck, and see you in class.